Using explosives to kill a well. That is today's topic. And I'm not talking about the time the Soviets detonated a nuke to kill a well that was blowing out.
The camera feels the impact of the detonation, and the gas flame begins to subside.
I'm talking about a much more refined and elegant solution. Although the nuke story is pretty interesting, so if you'd like a video on that, leave a note in the comments. Today, we're going to take a look at a relatively new technology in the well control space, the K BOS or Kinetic Blowout Stopper. This is Practical Energy Insights. Let's get into it. Let's start with some terminology, otherwise this video is not going to make much sense. When we drill into the earth, we drill into high pressure zones that contain pressurized water, oil, and gas. And it has risks, but most well programs are designed to control that pressure using the mud we use to drill, or with specialized equipment called managed pressure drilling. Sometimes, however, despite our best efforts, mistakes can be made either in the planning phase or in the execution, and we might drill into a formation that has higher pressure than we anticipated, or we may encounter a formation that all the mud effectively drains into and exposes us to other formations that have high pressure oil or gas. Or we may actually induce the kick by not managing our pit volumes effectively and pulling in a kick behind us. Whatever the case, the well kicks. And a kick is basically formation fluid, oil, gas, what have you, that enters into the wellbore. This is a situation that is manageable. We can shut in our BOPs, our blowout preventers, which shut in the well. The kick is a small amount of formation fluid, water, gas, or oil that will need to be circulated out of the hole. And we can calculate how much the pressure is and use that to increase our mud weight so that we regain an overbalance on the formation and can continue normal operations. There are cases, however, where our well control planning does not go as planned, and if that happens, we may have a blowout situation. This is getting close to a worst case scenario in well control. There are still options at this phase. We may still be able to shut in the BOP, but if the situation continues to escalate, then your options start to get more and more limited. In the worst case, a blowout preventer might not actually prevent the blowout. So what do you do when you need absolute shear and seal certainty? Right now, with whatever is across the stack, you might have pipe, a tool joint, drill collars, wireline, even big BHA or drill collars. That is where K BOS comes in. K BOS was designed by Kinetic Pressure Control and Transocean. It is a fast-acting shear and seal device that uses pyrotechnics and kinetic energy to close in under a second. Think of it like an airbag concept applied to well control. It is designed for the moment you absolutely must shut the well in, regardless of what is in the way. I'm sure many of you remember Deepwater Horizon in the Gulf of Mexico, known now as Gulf of America. In the oil and gas industry, we know this event as Macondo. After the Macondo Subsea blowout, the National Academy of Engineering recommendation was basically the industry needs a system that can shear and seal all combinations of pipe under all possible load conditions, including ugly, real-world stuff like flow effects and debris. Kinetic Pressure Control says the legacy answer from major manufacturers was essentially no. So K BOS was built as a clean sheet solution. Multiple Macondo investigations note that the BOP was the last barrier and it did not stop the flow. The K BOS comes in a variety of sizes. There's an 18 3/4 option rated for 15,000 PSI, targeted to be used in jackups and subsea applications on drill ships and semi-submersibles. There's a 13 5/8 bore rated for 10,000 PSI, aimed at common surface drilling BOP sizes, and a 5 1/8 bore 15,000 PSI system used for rigless intervention style pressure control scenarios. They're designed for extreme conditions. The 18 5/8 15,000 PSI system is rated up to 350 degrees Fahrenheit and water depths up to 12,500 feet. It's also compatible with sour service. which is H2S. At a high level, KBOS is electrically initiated and pyromechanical. It is very similar to an airbag type technology, and the exact propellant formulation is not something reputable sources publish in operational detail, so I can't tell you what that is. But here is an example of the sheer power of this blowout stopper. In this video, it has nearly instantaneously sheared a 9.5-inch diameter drill collar. This gives us tremendous shearing versatility to shear across drill pipe, tool joints, drill collars, casing, wireline, slickline, including combined casing plus drill pipe scenarios. And Transocean published a field note about a deployment and test on Deepwater Invictus, including shearing drill pipe at depths during a multi-month operational deployment. For offshore, this changes our catastrophe prevention and operational envelopes. The fact that KBOS can shear any wellbore component enables a simplified emergency disconnect sequence on the order of seconds compared with much longer baseline sequences. It can expand operability windows, especially when you are balancing dynamic positioning limits, riser angles, and rapid disconnect decisions. Once KBOS shears and seals, you have stopped flow through the bore at the device. But that is not the end of well control. How you kill and re-enter depends on where KBOS sits in the stack relative to your choke and kill flow paths, and what hardware you still have available. There are a few realistic pathways teams plan for. Pathway A, circulate or bullhead kill via available side outlets if the configuration allows access to the wellbore below the seal. This is configuration specific and must be engineered and planned for in advance. Pathway B is the retrieve and service. The airbag analogy matters. If you've fired the charge, you are planning for retrieval. You have to retrieve it, you have to inspect it, and replace any of the spent charges or damaged sealing components, any of the shearing components, before returning it to operation. And the third pathway is source control escalation. If you cannot reestablish controllable access with the existing stack, or if barriers are compromised, you shift to capping stack options, or in extreme cases, relief well planning, which is where you drill a nearby well to enter the wellbore that has blown out and try to kill it that way. That escalation mindset is exactly why Macondo created such a hard industry push for more reliable final barriers. Published public price lists are generally not available for this technology. Needless to say, since it's fairly new, expect pricing to be high. It is not a routine close-open device. It is a one-time actuation event like an airbag, and after firing, you are replacing the charge, inspecting and refurbishing to return it to service. Total cost is not just the tool, it's going to be integration, controls interface, offshore logistics, and the operational downtime it is designed to prevent. KBOS is basically the industry admitting that sometimes hydraulic closing time and shear uncertainty are not good enough. This is an attempt to make the final barrier decisive. Shear anything, seal instantly, and buy the crew the one thing you never have in a blowout, which is time. It is a really interesting technological development, one unfortunately born of a major incident and fatalities, as most of our safety systems seem to come from. If you like this video, please like and subscribe, and be sure to let me know if you'd like to hear more about the time the USSR used a nuke to kill a well long before KBOS was an option. That's all for today. As always, thanks for watching.